The recording, our final AP review session. It's Monday, June 7th. We're looking at the worksheets from the AP review materials folder. It's actually the CREAM worksheets. It's one of the last ones called medicinal algebraic techniques for anti-differentiating. So this is a worksheet that, again, that involves using some more advanced algebraic techniques to do the antiderivative. For example, let's say we have this integral here. So initially, you might think to do a u sub. Like initially, you might think, oh, let's let u equal x squared plus 6x plus 10. Then, of course, when you do the derivative, you get this, right? Here's a problem. Where's the 2x plus 6? Or anything that comes close to resembling that? I don't see it. So u sub's not going to work for us, unfortunately. We're going to have to get a little more creative. So how do I get creative? Well, what you do is take a look at this bad boy here and say, well, let's, separate out like this. Okay, and let me complete the square. And if you forgot what completing the square is, all it means is you take half of the linear coefficient like this and square it. So that's what I'm going to do. Half of 6 is 3, squared, I get 9. However, I got to put a minus 9 here. So the denominator, so the fraction, becomes this. Fraction becomes this. This is what I'm really integrating. So I rewrote the expression I'm integrating. Instead of x squared plus 6x plus 10, I have x squared plus 6x plus 9 plus 10 minus 9. It's the same thing. But why do I do it this way? Because now I have the liberty of doing this and think to myself, oh, okay. This is 1 over x plus 3 squared and plus 1 dx. Okay. Now what do I do? Now you can do a u sub. Now you can let u equal x plus 3. So du dx equals 1. Du equals dx. So now I have the integral of 1 over u squared plus 1 du. Now that we can actually integrate. How do I integrate that? Your cheat sheet's your best friend. If you want to use the cheat sheet we did last fall, which I have in the front page of School, I'll email to you guys, was a little more compact. This is just better. I think a little better because it's more comprehensive. But if you look at integral of 1 over u squared plus 1, or a squared, really the same thing. It's just going to be inverse tan of u. That's all. That's all it is, inverse tan of u. Or you can even see over here, inverse tan of u over a, where a is just something that you're squaring here. It kind of does like a u sub for you in a weird kind of way, but yeah. So there we go. So now I can integrate this. Those be inverse tan of u plus c. And what is u again? X plus 3. Inverse tan of x plus 3 plus c. There you go. But to derive that, it's 1 over x plus 3 squared and the plus 1. Yeah, you would get back to the original expression. So I know it works. And look at the answer, that's what we get, right? So that's one way you could go about this, do a complete square. So do watch out for that in case of a typical u sub, like letting u equal the denominator doesn't work. Now, if you could let u equal the denominator and then do the derivative of u, and then you could do the u sub all properly, then you integrate 1 over u. That of course would be natural log of u. We know that also. Let's look over here. So you have a monomial. Just divide each of these 4 terms by x squared. There you go. x5 over x squared, 7x squared over x squared, 5x over x squared, 3 over x squared. Simplify x cubed, 7, negative 5 over x, and always the y is a g there, that's a typo, and 3 times x is -2, and then just integrate. That's x4 over 4 times 1/4, of course. Sorry, x4 over 4, 7x. Now, derivative of, integral of 1 over x is natural log of x, so derivative natural log of x is 1 over x. And then 3x -2, add 1 to x1 divided by new x1, and then plus c. Let's look at over here. So again, you can't do a u sub. Like if I tried doing a u sub, supposed to be 3x squared. That's a problem because when I say dx, I get du over 3x squared. How am I going to get rid of this x plus 2? Even if you go x plus 2, you're going to have another problem. Derivative of x plus 2 is 1. How do you get rid of the x cubed then? So when you see something like this, you're going to have to think to do division. Now, it's not hard. Again, you have examples here. In fact, actually even print these notes if you want. Have them available to yourself when you're doing the test tomorrow, or sorry, not tomorrow, Wednesday. So the way synthetic division works, you put the coefficients of what you're dividing into in here. You start with the leading term, which is x cubed. The coefficient of x cubed is 1, of course. There's no x squared, there's no x, so you have to have placeholders. So you got placeholders, so you got to put zeros. Last term is a constant -3. If you don't have a constant shown, then put 0. You drop the 1 down, you multiply -2 by 1. Where that product is, you put it here, and then you add these two numbers. Then rinse and repeat. -2 times -2 is 4, 0 plus 4 is 4, just keep going. So this expression is the same as this, right? You just rewrote it to something else. Can you integrate that? Sure. That's easy. That's it. X cubed over 3, that's -2x over -2x squared over 2, 4x, and that's -11 times natural log of x plus 2 plus c. Okay. Or you do long division if you like. It's up to you. But what you've done is you essentially are transforming the expression so it's easier to integrate. That's what you do. Just like we did over here, just like we did over here. And then sometimes you have no choice but to do long division, because what you're dividing by is not a simple linear expression. It's x squared plus 2. So you do the long division. So you have to kind of buckle up and say, okay, let's just do it. So x squared goes to x cubed x times. You get x cubed, and then there's no x for what you're dividing by, no x terms. So you put 0 as a placeholder. Subtract. We subtract, usually like to do this. So x cubed minus x cubed goes away. 0x squared minus 0x squared goes away. 0x minus 2x is -2x. And that's your remainder. So it's -2x over x squared plus 2. Integrate this. That's easy to integrate, the first part. The second part will require a u sub. So it's kind of a cruel problem, to be honest with you, because it's actually now asking to do a u sub within another problem. So it's a little bit advanced, but it's not hard. You let u go x squared plus 2, u over dx equals 2x, isolate dx, or you could do, replace 2x dx simultaneously, replace that du, work all out, you're good. Get the answer. You're a-okay. Okay. So and of course, if you do the derivative of this and combine some things, you would get back to x cubed or x squared plus 2. I think now would be a good time to do some practice. It's just a good practice of integration in general, knowing a lot of your rules. I'd like you guys work on this worksheet before we move on to doing some free response problems. And we will do the free response problems from the mock exam that I published on the Albert.io website. We'll do definitely one calculus problem, 2 non-calc problems. And if we have time, we'll do more other problems, but at least we'll do that just so you get a kind of a thorough review. Again, if you guys have specific questions, if anything's really burning, like I really just totally forgot how to do related rates. I really want to see a volume problem. Optimization, please show me that, or L'Hopital's rule, whatever. Just let me know. Just put in the chat, and I'll find problems that are similar to that cover that topic. But if not, if you're kind of just being very lax, not lax, right word, but just kind of open-ended or open-minded about this, then I'll just do an overall review like I planned. So anyway, let me have you guys work on these problems. We'll just do 1 through 5. I think that will be sufficient. I don't think we necessarily have to do. I mean, the ones that are a little more challenging, and I think I have the answers for these, by the way. I sure do. And I think these answers are in Schoology. Yep, they're there. Okay. So let me have you do 1 through 5. I'll email it to you guys in case we don't have these worksheets. So again, we're just doing the PDF that says worksheets. If you have the hard copy, then of course it's doing the hard copy. It's cream colored. And we're working on just page 13. It's the last sheet. Let me email it to you guys as well. I'll give you guys, let's say 10 minutes. I think it's fair. It's kind of what they would, these would probably, multiple choice questions, my guess, without a calculator. If you have a question, just ask, or you can like ping each other in the chat, or just text each other, or whatever, however you guys communicate. So give me 1 sec here. I'll email to you guys. So resume recording. Let's take a look at the answers. So give you guys plenty of time to work through those. And let me share my screen. Okay, screen's being shared. So here are the answers. For number 1, the best way to handle that one is divide each term in the numerator by x squared to get x cubed minus 3x plus 7 over x squared. The over x squared would be rewritten as 7 times x to the -2 power. These are all power terms. When we do the anti-derivatives, add 1 to the exponent, divide by the new exponent. There you go. And don't forget the plus c at the end. Of course, if it's multiple choice, plus c will be in the choices. But if it's free response, then of course put plus c at the end. For number 2, you have an expression being squared. So you could actually FOIL it. That's what was actually being done here. So you do x to the -2 plus x squared root 5 times itself. There's actually a foiling process that's going on here. Let me do a different color for a bit of contrast. Okay, so first, outside, inside, last. There you go. Work it out, you're good. And then you just do the antiderivative. So that's what happens for that one. So sometimes you gotta look for that, if you have that opportunity. 3 is a little strange. You can factor out 3 from the bottom and then pull the 4/3 out as a constant. And you should hopefully recognize that this is just the inverse tan. So that's what's going on there. For 4, synthetic division, you could divide by x minus 2. So put 2 on the outside, bring the 1 down. 2 times 1 is 2, add them up. You get 2, 2 times 2 is 4. Just keep going and you're good. There you go. And then once you have the new expression, do the antiderivative. That's easy. You guys should know how to do that. And whenever you have 3 over x minus 2, something like that, it's 3 times natural log of that expression. You can do long division too if you wanted. Totally up to you, get the same results. For the integral, sorry, for the expression you're integrating, then you just do the rest. And then here, you can rewrite it like this, where you take half -10 squared, add it, you get, so you could have actually done this, actually. Leave the 26 off to the side. Take half -10 squared, that's 25. But then you got to put minus 25 here. So you focus on this part, which is x minus 5 squared, and 26 minus 25 is plus 1. Recognize it's that. There you go. Any questions about those 5? Okay. So I think now is a good time to move on to the our IO problems. Let's look at mock exam Let's look at the questions themselves. And actually, hold on. Multiple choice with calculator. So there are a couple of guys that took it, so I'm just going to kind of go through the ones that gave us trouble. I feel like I've done this one. Yeah, I kind of did some of these problems. Let's go to actually, let's go to free response because I said I was going to do that instead. So let's just do that right now. Let's go to questions. Let's do this one here. So let me do one free response and then have you guys try one. Okay. So here's the problem itself. It's a table problem. A blacksmith is constructing a sword and is working with new metal. The process requires metal to be heated to a temperature of 986 degrees Fahrenheit before allowing it to air cooled for 25 minutes. The temperature of metal as it air cools can be modeled by twice the differential function m of t. Values of m of t, that's the temperature of the metal, from 0 to 25, because t is in terms of minutes, are provided by the table above. Now, the first question, is there a value t between 0 and 25 where the derivative will be -5? Okay. Well, give me one sec here. Let me think about this one. I believe the answer is going to be yes, but here's what I would wind up doing is I believe it's going to be a mean value theorem problem, or it could be intermediate value theorem for derivatives. Not 100% sure, but if you do the average rate of change, we should know where c is going to be some value between 0 and 25. This is part of the mean value theorem. So the average rate of change will equal the derivative. And you know, this has to be true for differentiable and continuous functions. And you're told it's twice differentiable, you can do the second derivative. So if I do m of 25 minus m of 0 over 865 minus 986, sorry, over 25 minus 0, what? I can't believe I just did that. So 865 what do I get? So I get negative 4.84. And it looks as though that's going to be probably the biggest average value I get, or lowest, because negative. Kind of look at any other possible intervals. I don't think I could ever get close to negative or exactly -5 or less than -5. Actually, let's do this. That's kind of interesting. What if I did this here?
What if you get one that's over it and one that's under it?
Then you're using intermediate value theorem.
Yeah.
Yeah, and I think that's what we're going to get to. It's IVT for derivatives. Yeah, I think that's what's going to happen here because I'm going to have 865 minus 905. And I get 5 down below, so it becomes -40 over 5 or -8. So when I went from 0 to 25, I had -4.84. went from 20 to 25, I had -8. So because this is in between those two numbers, the answer is yes. And that's because of the intermediate value theorem for derivatives, which is something we didn't really quite talk about. They did something kind of crappy. They did something for, you have exactly, I think they would accept the IVT argument, just so you know. But they did from 20 to 5. I think on the real AP exam, they would just tell you from 5 to 20, or they make sure from 0 to 25 that it was exactly -5, the average rate of change. The average rate of change from, I guess, from 5 to 25, in this case here, or was it 5 to 20, my bad, was precisely -5. So by mean value theorem, sure. But then you have to kind of do the whole trial and error. Like, they don't really ask you to kind of look at it in that way. But notice my initial instinct was mean value theorem and finding average rates of change, because I wasn't finding it easily. So then I realized, well, I could do an IVT for derivatives, which means that it's intermediate value. So if you have so IVT for derivatives just means this, that if you have one derivative, let's say it's like that, another one's like that, and say that derivative, let's say f prime, let's say it's a here, is like 1. Say it's b and f prime b is, say, like 5. Then f prime has to be between of c, somewhere in between. Well, between 1 and 5. I know that. That's what I was using. But anyway, let's keep moving here. Use the correct units, use the table to calculate n prime 17 and interpret its meaning in context. Yeah, I'm really not like it. I think Alvarado makes these more challenging. They should have done 17.5 or a number that's halfway between, but you could look at 15 and 20, for example. The curve kind of does something kind of like this, right? So 17 is in between. So whatever tangent I have at 17 is going to be pretty similar to the secant line through 15 and 20. So you can just find that average rate of change, which is 905 minus 925 over 20 minus 15, which is -20 over 5, which is -4. And don't forget the units, -4 degrees Fahrenheit per minute. So you would say, how would you interpret it in context? You would say this would represent the instantaneous rate of change of temperature versus time, or at 17 minutes, the temperature is changing by -4 degrees Fahrenheit per minute at that moment. You could say it like that as well. You can look at their explanation. Yeah, at the rate which most terms is changing -4 degrees per minute. So you basically got to tell me the quantity, the what, the quantity, and then the units that go with it. That's what we're looking for. For C, use a trapezoidal sum from 5 to 25. So trapezoidal just means that you're doing, it's like a Riemann sum. What you do, the area of trapezoid is 1/2 B1 plus B2 times H. And again, the things that, like that one file, things you should know cold. I'm pretty sure there's a trapezoidal approximation. I thought for sure there would be one. They have Riemann's. Oh yeah, there it is, right there. Okay. So yeah, coming back here again. So if you want to do that, you put the 1/2 on the outside. and you focus on this interval first. So the way this would look, here's 5, and the y value goes to this 980. Here's 10. The y value goes to that's 971. So curve does something kind of like this, right? So you kind of have to tilt your head a little bit. That's actually going to be your height of the trapezoid. Trapezoid looks like this. That's the height, and that's B1, that's B2. Okay. Really, it's kind of like this. So it's kind of weird, but sideways, where the actual height is resting on the x-axis. So the height's going to be determined by the difference in the x-coordinates. Your B1 and B2 are going to be the y coordinates you see here. So you're going to be doing 980 plus 971 times 10 minus 5. And then you have to actually do this 3 more times because you want 4 subintervals. So then you do from 10 to 15, 15 to 20, and 20 to 25. So plus, that'll be 15 minus 10 plus 20 minus 15 plus 25 minus 20. And then you have to put the y values here. So I did 98 plus 971 for the first one, 97 plus 925 for the second one, 925 plus 95 for the third one, 95 plus 865 for the last one. And then, yeah, you just work it out. You actually can leave your answers like that, just so you know. It doesn't have to be simplified. But do state the units. Because you're doing area, so you have like all the y values times all the x values. So it's basically, it's interesting because you're actually, you're not integrating a rate. So it's just going to be degrees Fahrenheit times minutes. So it's kind of weird. I'm not sure why they would do that. Usually could be a rate here. Let's look how they interpret the units because it is kind of weird. It is not the net change in those temperatures. Actually incorrect. It's just simply minutes, temperature times minutes. Kind of weird. Don't know what they were thinking here when they designed this problem. I mean, the setup is fine. I think you guys saw that. It's not the change in Mel's temperature. I am 100% sure that's wrong. So that's interesting. Yeah, it's just some weird quantity, temperature, Fahrenheit times minutes, whatever. But for a rate, if the second row is like a rate like Fahrenheit per minute, and you integrate that, then there would have been the change in temperature for sure. When you're integrating a rate, so the integral is net change. Lastly, let's look at part D. Then I'll have you then try free response question 2. And what I'll do is I'll probably do a screenshot and email it to you guys. I've lined the metal to air and cool for 25 minutes. Black must submerge hot metal in cold water and allow it to cool for additional 5 minutes, from 26 to 30. The instantaneous rate of change there. The potential is 360 degrees at t equals 26. Find the temperature at t equals 27. Okay, so that's the integral's net change. So what you're doing is you're integrating c prime of t from 26 to 27. And that's going to be c of t, dt. And that's going to be c of 27. Repeat that, c of 27 minus c of 26. Well, c of 27 is what we want to find. C of 26 knows 863. And here you have to use your calculator to work that out. So you have this one here. Don't do that by hand, please. So alpha window, fn int, 26, 27. negative 2000 sine x times e negative 0.2 root x yeah, so you get about next, I get negative 670.59 is of course in degrees Fahrenheit. Well, they should have told us what the units were. Yeah, they didn't do the best job designing this. I think they kind of rushed it. Oh, plus 863, my bad, plus 863. So I get 192.414. Because I have to add the 863 over to the other side. Okay, so we're okay now. Okay, so let's try this next. This is the linear motion. Actually, let me expand my screen. I don't need to do a screenshot. I'll just kind of leave like this. So if you just be working direct from my screen, let me stop the recording or pause it. Okay, so look at number 2 of this free response. So for part A, they want you to find the acceleration. All you have to do is do v prime of 2. For what that is, and of course use your calculator because that's really, really nasty. So I'll get you the acceleration. And if the speed was slowing down, speeding up, B and A have to be the same sign. Slowing down, B and A must have the opposite sign. Because if your acceleration is positive and so is your velocity, that means the acceleration is causing more of a positive change in the velocity, so it's going to speed up. Likewise, if the acceleration is negative, velocity is negative, it's going to cause more of a change in the opposite direction and keep going in that direction. When they're opposite of each other, the signs, they work against each other. If your velocity is positive, your acceleration is negative, it's like you're hitting the brakes. And vice versa, if your velocity is negative, you're pointing towards the other direction, your acceleration is going positive. Again, they're working against each other. So the answer is right here. V prime is negative 1.117. The velocity at 2, which you actually have to plug 2 into the velocity function itself, is 0.34. So the opposite sign, you're slowing down. Find position, what you want to do is you want to, it's FTC again. So the integral of velocity, dt, from 0 to 2 will be your position. These like x, I guess, for position. You can use s, I don't really care. But is that, and you know the positional position is negative 2, so you put that instead. And of course, you're integrating from 0 to 2 of this expression right there. You can work it out. So here, use your calculator, and that's going to represent the average velocity, just so you know. That's average value. And of course, in no, they don't give us units, so it's average velocity. So look at the answers there. Again, that's what we have for part B. Part C represents, oh shoot, I lied, it's not average velocity. It would be average velocity if you have this. My bad, it's total distance. This is why the cheat sheets can be your best friend. It's right here. My bad, that's the total distance during that time interval from 0 to 5. I do round to 3 decimal places or cut off up to 3 decimal places. And then the average velocity, that's where you have to do 1/5 minus 0. There we go. But you don't do an absolute value. Sorry, that's just, if I did have an absolute value, actually, I'm not sure what that would represent. Because it would make sense to say average distance, but yeah, that's average value of velocities right there. And scoring looks like I'd be surprised if that'd be worth 3 points per part A. But definitely 1 point for find the velocity and, or so the acceleration. I guess you have to find the velocity and so it's slowing up, speeding up or slowing down. That's the initial position. Yeah, 1 point for each initial position, 1 point for integral expression, 1 point for the answer. Average velocity, I guess 1 point. And then this one, get the answer and interpret it correctly for total distance. Okay, so let's move forward. Okay, let's do accumulation. Then maybe we'll do different equations after that. Okay, so this is a very traditional AP style problem. We zoom out. Hold on. Huh, not sure it's not resizing it. I think that's good enough. I think we could position it like this. Hold on. Let me copy that part and just put it right here. What did I just do to myself? See here. Okay. So the function is defined by default. So first of all, you have a piecewise function here for f of x. X minus 1 squared is the parabolic part from 0 to 3. Okay. G of x is defined as the integral from -3 to x. So first off, you'll probably want to say that G prime equals f. And G double prime equals f prime. We want to kind of get that out of the way first. Then let's see here. Find by f prime of 3. So that means that's going to be, well, you just look at the graph, I guess. That does not exist because you have a corner, because the left-hand derivative will not equal the right-hand derivative. And probably mentioned they have a corner. Now, G of 3 is actually the area. So you have this region. So this right here, that's -2, and that's -1. So that area is going to be, I think, 0.5. And that area is going to be, I think, -2. Then you have to integrate this from 0 to 3. So That's x squared minus 2x plus 1. Integrate that from 0 to 3. Work that out. That's x cubed over 3 minus 2x squared over 2 plus x plus c. We don't really need to worry about the plus c, but then you're plugging in 0 and 3, plug in 0, everything goes away, plug in 3, you get 9 minus 9 plus 2. So that's an area of 3. So it's 0.5 minus 2 plus 3, that's 1.5. And g prime of 3 is just going to be f of 3, and that's easy, that's just 4. So let's make sure everything's going okay so far. Yeah, the left-right derivatives don't exist, they don't equal each other. And you could actually try finding it. The right-hand derivative obviously is just going to be a slope of that first segment, which is going to be, I think, negative 1/3. The other one is just taking the derivative, 2x minus 2. And then plug in 3, you should get 4. Yeah, 4. And actually, the right-hand derivative was that. One sec. Yeah, they have the right-hand derivative incorrect. It's actually negative 1/3. But anyway, regardless, they're not equal to each other. It doesn't exist. And then yeah, 1.5, we got that part right. And the other part's is 4, so that's easy. Okay. For part C, find the value for x, for which, find the value of x, okay, for which g has a relative maximum. Okay, so it's an EVT product, extreme value theorem. We haven't talked about that yet. You do have to test the endpoints and then also the critical points. So you want g prime or f to equal 0. Well, f equals 0 here, here, here. But since you're trying to find a max, you want to really kind of see a sign change or at least a relative max, which I know is going to happen there. So I don't really need to waste my time trying -4, but I'll definitely try -2 out. And here you're not going to see a sign change, so I know it's not going to be a relative extreme. So I don't need to waste my time at whatever this x value is, which I think is, yes, it's that 1. So really I'm just going to make a table for x and g of x at the endpoints, -5 and 6, and at -2. Now we just did an integral from -3. Well, first of all, for -3 and -5, you're going to have two regions canceling out here. So I know that's going to be 0. And from -3 to 3, I know it's 1.5, and I'm adding a little bit more, which is 3 and 3, that's 9. And that's 3 and 1, that's 1.5, so it's 10.5. So that's going to be 12, actually. And then from -3 to -2, thank God, that's going to be real easy. That's just going to be 0.5. So it's pretty clear absolute max happens at 6. And you can see they kind of test it out. Oh, relative, wait. That's for absolute max, isn't they? Oh, relative max. Okay, then I know it's -2. Okay. So, well, anyway, I'm glad I did that anyway. So if they want that, then you just have to see the sign change. There's a sign change at -2. So that was easy. That was not that hard. I made that problem more challenging than I should have. They just want to see it. Remember, g prime equals f. And so you need g prime to go from positive to negative, or f to go from positive to negative, which totally happens like right there. Because here it goes from negative to positive, and here there's no sign change. And finally, this is a L'Hopital's rule, because if I were to plug 2 in, I'd have f of 2. Sorry, plug in -2, f of -2 over 4 minus 4. And f of negative 2, according to the graph, is 0, right? So that's a problem. So I'll have to do the derivative. So it'll be f prime of x over 2x plus 2. So it's f prime negative 2 over 4. Oh, sorry, 2x plus 2. Yikes. If I plug in negative 2, I should get negative 2 on the bottom. So I get negative 4 plus 2. So you get negative 2 on the bottom, f prime negative 2, according to the graph. That slope is just going to be 1. No, sorry, negative 1. So really just find the slope of the graph over here. You know, down 1, right 1. So it's just 1/2. That's it. Yep, you get 1/2. So the Liptals were 2 points, the relative between 2 points. Part B was a little more involved because you had to find g of 3 and g prime of 3. I think I just have the integral expressed up correctly, g3 being one, well, being point g prime being another point. And of course, part A was proving that limit does not exist, or said derivative does not exist. That's because the left and right derivatives are not equal to each other. So, okay. So let's do that one for about 10 to 12 minutes. Have you guys try this on your own. So let's do a differential equation problem. So you're asked to find the second derivative, you're asked to write an equation tangent, and then find the solution to the differential equation. This is a very quintessential problem. So I'll give you guys about 10 to 12 minutes. We'll say at 1:55. We'll go over it really quickly, and then we'll wrap up our call. And then we're done. So it's very exciting. So now I'll hit pause right now. Okay. So for part A, you can see I worked out the second derivative by taking the derivative of dy over dx. So I did the operator d dx of both sides. On the right side, doing the derivative of 2x over y, so that's going to be a quotient rule. You can do the derivative of 2x, which is 2 times y minus 2x times derivative of y, which is y prime, over y squared. Y prime holds a value of -1 when you plug in 1 and -2, because you have y prime dy over dx given to you in the problem. And then, of course, plug in 1 for x and -2 for y into your expression. You should get -1/2. For B, you were asked to write the equation of a tangent line. So what you want to do is do point slope form. You do y minus y1, which is y plus 2, equals m. We know what m is at 1, -2. We already did in part A, which is -1 times x minus 1. Then plug in 1.2 for x and solve for y. You should get -4.4. And that's going to be an over approximation because we know we're concave down at 1, -2. We just did that in part A. We solved for the second derivative. We're concave down. The tangent will be above the graph, making it an over approximation. So you can see here, yep, -1/2. Yep, y plus 2 negative parentheses x minus 1. Should be -4.2. They forgot to move the 2 over. So yeah, notice mistakes here. But
wait, Mr. Malashny?
Yep, good.
I think it's actually -2.2. Like,
Oh.
I think you messed up your math a little.
I did actually. You're right. I did. It is -2.2. So, okay. So I've lost the point. But I've got everything else. Yes. Okay. Thank you for correcting me on that one. Good. I'm glad we got that recorded. Yeah, I was thinking -1.2 minus 1, too many negatives. So thank you for catching that. Then lastly, for part C, yeah, just separate. So you get, y dy equals 2x dx. It's actually one of the easier ones to do. Hopefully it'll be that kind to you on Wednesday. So you get 2x squared over 2 plus c. 2's cancel. Plug in your initial condition, which was 1, -2. So you should get 2 on the left side and 1 on the right side. So c is 1. So now your equation is going to be y squared over 2 equals x squared plus 1. So right off the bat, I've got most of the points for the problem. The algebra is not going to be worth all that much. We'll change colors here. Multiply everything by 2. Square root That's plus or minus, mind you. Because y is negative, you're already going to have to go with the negative on the outside the radical. And if you were plugging 1, you would get -2 for y. So that's going to be your answer for that one. Yep, y equals -√2x squared plus 2. 2 points for part A, which I think would make sense. You know, doing the chain rule, implicit, whatever you want to call it, and then get 1 point for getting the answer. They have 3 points for part B, getting the equation of tangent line, estimating, and of course giving the reason. And yeah, 4 points, separating, integrating, finding C, and then the actual answer. So usually those are worth 5 points for something like part B. These said there were 6 points back in the day. It was kind of an easier one, I suppose. But yeah, I think that's a good kind of problem that kind of covers everything. Okay, we're at 2 o'clock at the dot. All right, that's it. We're officially done. I'm super excited to finally officially close the books on the 2020-2021 school year. Even though it was over last week, we had our final faculty meeting last Tuesday, but I had to make sure you guys were in good shape. And I feel you guys are going to do great. If you have any questions, let me know. I'll shoot you an email with those links so you guys have, just make sure you download that app. Obviously, if you're Mac, then obviously do it for Mac. I mean, I'm on a PC right now, so that's why I'm guessing the things for Windows. But yeah, I'm sure you have Windows 8 or later. I'd be shocked if you have Windows before Windows 10. Anyway, yeah. So, I would just relax the rest of the day. If you want to do a little extra work, you can. There's a lot of worksheets and pre-response problems I've given you guys where you can look online. Albert.io, you got stuff there too that I've shared. Yeah, just tomorrow relax and take it, and I'll solicit your feedback after Wednesday to kind of see how you guys felt about it. Make sure your calculator's working. Make sure you have food ready, sleep. Good thing is that you don't have school. I think most people are done with school by now. And I think a lot of people who probably had finals probably chose not to do the AP at this time. So yeah, I think a lot of people are going to be in a nice position. Yeah, and the scores probably won't come out till middle of July. I'll follow up with you guys. If you're a senior, obviously, you're ready into a college, but it could be worthwhile for the college credit. Of course, if you're a junior, the data points can help for college admissions for sure, and validate pretty much your grade in the course. So yeah, again, good luck, and I will, if you're a senior, it was a pleasure. Hopefully our paths will cross again at an alumni event, or I tend to run into people all the time. You should ask where I've run into 2 former students in Las Vegas, one at the blackjack table, believe it or not, at the Bellagio. One at the airport on a Sunday morning. I've run into people at Carmel and Maui, you name it. Ran into someone on an airplane to Portugal who actually knew someone. We both knew the same person for Sacred Heart. So you never know. We might run into each other. And of course, if you're a junior, I'll see you on campus. I'll see you around. So, okay, well, enjoy the summer. You guys, well-deserved break. Actually, I've recorded that part about Vegas. So who cares? Okay, cool. Good luck to you, and yeah, just look for some emails asking for your feedback in a couple days. All right, take care.
Thank
Thank you
you.
so much.
Thank you so much.
Welcome.
Have
Yeah,
a great
welcome.
summer.
Thank you.
My
Bye.
pleasure. Yep. Bye.